Okay, class, picking up where we left off at, we finished up part A, but we need to do parts B and C. And I took the liberty of writing it out only because what we did for part A is what we would do for part B and C. So we could take our time here. We have our BMI is equal to 703 times the weight divided by 5,625. Remember, we figured out that he was 75 inches tall, and that was the height, and we were supposed to square it, which gave us 5,625. And we know without our weight, our numerator would be 703 times the weight. So now they give us a BMI of 25. So we substitute in 25 for the BMI, and that's equal to 703 times W over 5,625. And just like in part A from the previous video, we had to multiply each side by the reciprocal, which would be 5,625 over 703. Once we multiply these across the top here, this will give us 140,625 divided by 703. And that would equal to the weight because all of these values here would simplify out. Okay, now, when we divide these two values here, it will give us approximately 200 pounds. Because remember, we want to round it to the nearest whole number. Now we come here to C. C is basically the same thing. We put in 30 for the BMI, and it's 703W over 5,625. We multiply each side by the reciprocal. And then when we multiply this fraction by this fraction here, we get 168,750 divided by 703. And once we put that in our calculator, it gives us about 240 pounds. Now we move on here. We go here to the next problem. It says Sally's weight is 115 pounds. What is her simplified BMI formula? How does it differ from Phillips? So I have number 2 over here. So we would take 703 and we will multiply by 115, and then we will multiply by the height squared, or divide it by the height squared. We don't know what the height is. So we have our BMI. So we have BMI is equal to 703 times 115 is 80,845 divided by the height squared. Now that is the simplified BMI here. Now, it says, how does it differ from Phillips? And Phillips, remember, we had the height and we didn't have the weight. So that's the only difference, that we have the weight here, but we don't have the height. So that's the only difference between the two. Okay, number 3. It says, Sally has hit a growth spurt. 4 months ago, she was 5'3", 5 feet 3 inches tall. Now she is 5 feet 6 inches tall. She has maintained her weight at 115. Find her BMI both 4 months ago and now. How has it changed? Now, we're going to go with her first weight, which was this 5 feet 3 inches tall. So we would have our BMI is equal to 80,845 divided by 5 feet 3 inches tall is 63 inches. Remember before, when we did 5 feet came out to be 60 inches, and we have 3 left over, so it'll be 63. And then when we square that, that will give us 3,969. So we will have 80,845 divided by 3,969, which will give us an approximate BMI of 20.4. Now we go with her growth spurt. We still would take the BMI being 80,845, but because she's 5 feet 6 inches now, it'll be 66 we will put in for the height and square it. When we take 66 squared, it'll be 4,356. Now we would take 80,845 divided by 4,356, and the BMI is 18.6. So basically what you could say here is that since she maintained the same weight but got taller, her BMI got smaller. Okay, now we look here at number 4. Now it says Sally continues to grow to grow taller while maintaining her weight, so she's still 115 pounds. She eventually reaches an unhealthy BMI of 18. How does this problem differ from question 1, where you were given BMI values for Philip? Okay, first of all, none of Philip's BMI values were less than the unhealthy weight, and that's under 18.5. Okay, that's number 1. Number 2, we actually had everything. We had the weight and we had the height before we saw for the BMI. But in this case here, we have the BMI, but we don't, oh, I'm sorry. What we originally had was we had his height, but we didn't have the weight. And when we were given the BMI, we had to find out what his weight was. In this situation, we'll be given a BMI of 18, and we will have to figure out what her height is. And that is the differences between the two. Now, class, we move on to lesson 14, part C, with the blood alcohol content. And it is a measurement of how much alcohol is in someone's blood. It is usually measured as a percentage. So a BAC of 0.3% is 0.3%. That is, there are 3 grams of alcohol for every 1,000 grams of blood. A BAC of 0.05% impairs reasoning and the ability to concentrate. A BAC of 0.30% can lead to a blackout, shortness of breath, and loss of bladder control. In most states, the legal limit for driving is a BAC of 0.08%. BAC is usually determined by a breathalyzer, urinalysis, or blood test. However, Swedish physician E.M.P. Widmark developed the following equation for estimating an individual's BAC. This formula is widely used by forensic scientists. So as you see here, we have B equals negative 0.015 times T plus 2.84 times N over W times G. Now, if you look here, these are what each of these mean here. B is the percentage of BAC. N is the number of standard drinks. And then it says the standard drink is 1 12-ounce beer, 1 5-ounce glass of wine, or 1.5-ounce shot of liquor. W is the weight in pounds. G is the gender. And if you notice here, well, let's look down at T before we go into the G. T is the number of hours since the first drink. Now, G is the gender constant. Now, this would be the only difference between the male and the female is the gender constant. Because if you're a male, you're supposed to use 0.68. If you're a female, you're supposed to use 0.55. Okay, so now, it says here, look at the right side of the equation. Now, I wrote the equation here. It says, look at the right side of the equation. How do the variables in their location make sense in calculating VAC? For example, based on their locations, which variables would make VAC larger, which will make it smaller? Okay, so in this case, when they ask this question, I'm going to speak this out, and you can rewind this as needed to write down what I'm about to say. Basically, the time is multiplied by a negative. Again, the time is multiplied by a negative. So it will reduce the BAC as time passes. So it will reduce the BAC as time passes. Number of drinks is in the numerator. So that will increase the BAC. Number of drinks is in the numerator. So that will increase the BAC. And larger weights in the denominator will decrease the BAC. And larger weights in the denominator will decrease BAC. Now again, you can rewind this and rewrite what I just had spoken. Okay, now number 2. It says, consider the case of a male student who has 5 beers and weighs 180 pounds. Simplify the equation as much as possible for this case. What variables are still unknown in this equation? So what I did here, I took the liberty of writing this out so you can easily see it. So now we have this formula here. Now we're going to do some substitution. First of all, this is B is equal to a negative 0.0. It's supposed to be 1.5 here. So it'll be a negative 0.015 times t plus 2.84 times 5, because remember it was 5 drinks. N stands for the number of drinks. And then his weight, which is W, is 180. And the gender constant, since he's a male, is 0.68. Now when we multiply these values, 2.84 times 5 is 14.2. 180 times 0.68 is 122.4. So we have a negative 0.015 times t plus 0.116 when you divide this out. Okay, so this is your new formula, the simplified formula. Now they say what variables that we don't have. We don't have our BAC. We know B basically stands for the BAC, and then we don't have how much time has elapsed, which is our T. So we don't have our B or our T. Okay, now we go here to number 3. Number 3, it says using your simplified equation, find the estimated BAC for this student 1, 3, and 5 hours after his first drink. Okay, so what I did here, I took the liberty of taking this equation, and for T, I substituted in 1 here, 3 here, and 5 here. So we had a negative 0.015 times 1, which gave us a negative 0.015. And we add the 0.116, which gives us a final answer of 0.101. Now for our B here, with the 3 drinks, it's basically the same setup, except for we multiply this by 3, and then we add these two values together, and it gives us 0.071. Then finally we do the 5 drinks. Same formula, except for we multiply this negative 0.015 times 5. And we add it to this 0.116, and it gives us 0.041. Now, for number 4, it says record the sequence of steps you took to get from the time to BAC. Be specific. For example, did you multiply, add, subtract, etc.? What values and in what order? Okay, since we had this simplified equation here, we substituted in the amount of drinks, which was our T. Which was our T. We substituted in the 1, 3, and 5, which was the hour since we took our first drink, after our first drink. And then we multiplied, and then we added. Those were the steps. Substitute, multiply, then add. We basically followed the order of operations. Okay, now we go here to lesson 14, part D. It's basically using the same exact formula. But when we go here, our questions are a little different. So I didn't really need to read all of D, but we could come here to these questions. It say, how long will it take for this student's BAC to be 0.08, the legal limit? How long would it take for the alcohol to be completely metabolized, resulting in a BAC of 0? Now, there is one thing that we actually need from here. It says that this is a 180-pound male who drank 5 beers. So, we're going to use that information. So, using that, and I guess I'll write this out. And I think we already actually, in class, it's just as I thought, we actually figured this out already from the previous example with the 180-pound person who drank five beers, the male. So this simplified formula that we had before in 14C is a simplified formula we would use here. Now they tell us that we want to get a BAC of 0.08, so that replaces B, and then we set up this problem here. We have 0.08 is equal to a negative 0.015 times T plus 0.116. We'll subtract 0.116 on both sides, and that will leave us a negative 0.036 is equal to a negative 0.015 times T. We divide each side by negative 0.015, and that will give us 2.4. So that'll be 2.4 hours. Now the last thing here is for the 0 to get in a BAC at 0. So we'll take the same formula but put in 0 for B and go through the process of subtracting 0.116 and then dividing each side by negative 0.015. And it's 7.7 hours for T. and complete number 2 on your own.